We are all set to begin yet another exhilarating day that has powerful content lined up for the day. And it starts with the first tech Pathshala for the day. And for this, let me introduce our first tech guru for the day, Mr. Kishore Sheshagiri, to present the key insights on blockchain and why it matters. Mr. Kishore is an executive vice president at Broadridge, a fintech leader with 20 plus years of experience in the capital market and wealth management technology solution. Let's all welcome Kishore. Over to you, Kishore.
Thank you, Sandeep. Good morning, everyone. It's a pleasure to be here. Thank you to NASCOM and the NASTech event organizers for inviting me to do the session, the Tech Pathshala session. And thank you to all who taken their time off early morning, at least Hyderabad standards, to log in at 10 o'clock to listen to this session on blockchain. And I hope I can keep you guys interested for the next 1 hour, and hopefully what I can talk about is meaningful enough for you to inquire and research more on blockchain and upskill yourself. Sandeep and team, if you could bring up the presentations. So today's topic, as Sandeep was mentioning, is called as blockchain, why it matters. I suspect that a lot of folks here who dialed in probably are already experts in blockchain. And I also expect that there are people in the spectrum of people who joined today who are fairly new to blockchain. And so I thought, what I would do over the next hour or so is to keep this discussion or the presentation at a level which is something that introduces people to blockchain. I wouldn't call this as a deep dive on blockchain, but more so probably a blockchain 101, right? Blockchain as a technology is generating a lot of interest. It is it's a rabbit hole, and once you get into it, you will start learning something new every day, right? And so I thought it is best that we keep the session at a level where it generates curiosity in the people who are logged in and listening to the session, right? So I think Sandeep did speak that I come from financial services and fintech, so it is only appropriate that we start off with a disclaimer, just like any other mutual fund company would do. The views expressed in this presentation are of mine and not necessarily of my esteemed organization Broadridge. I also have another disclaimer, right? When Sandeep and team reached out to me talking about this Tech Pathshala, and they had called this session as a masterclass. And so I was curious to find out, the history behind why certain classes are called as masterclass, right? And apparently, the word masterclass originated from the classical music world, wherein you would have these sessions where experts and masters and gurus would have deep dive sessions with their students and focus on specific area, right? And I would say that with the fact that we are doing the session and over in digital medium and not in proximity, this session probably under the classical definition of masterclass, I wouldn't term it as masterclass. And so that means a lot less pressure on me, right? I mean, I can easily say that I don't claim to be a master of blockchain. So with that being said, let's just try to get some interest generated on blockchain, right? So I've been working in blockchain / enterprise DLT now for maybe just over 6 years. And one of the things that I've always tried to do is to sort of understand the interest levels in this technology, right? I mean, I'm sure most people would want to understand what is the interest level in any technology that they're working. So I was just doing some quick analysis using Google Trends. Not always the best data analysis, but it gets your job done. It's also very interesting to see who's searching for what and why are they searching, from where they're searching, right? So this is a Google trend. I just used how is the interest level in the term blockchain over the last 5 years. And if you look at it, nothing extraordinary around it, ups and downs, just like any other search word would be, right? But then I sort of did a comparison of the word blockchain with word Bitcoin and cryptocurrency, right? And this is very, very interesting. If you look at it, pretty much all of them follow the same patterns. You see the spike in the interest of each of these words at pretty much the same time. But if you look at the interest levels of Bitcoin in a relative way to cryptocurrency and blockchain, you would see that the interest levels of Bitcoin is so huge, right? What this potentially tells me and probably us, even though the data scientist would say that correlation doesn't mean that there's a causation, but it's very likely that people got very curious about the rising prices of Bitcoin, and every time there is a spike in Bitcoin, people were curious to figure out what is this Bitcoin, and that led them to a rabbit hole of okay, Bitcoin runs on blockchain. What is blockchain, right? So that's probably how people got interested in blockchain. And every time there is a price increase in Bitcoin, you would see that there is the interest levels in blockchain also goes up, right? And why is it important for blockchain as a technology? Looking at that, right? If you look at any emerging technology, be it IoT or AI or any technology going back in time, the typical life cycle of it would be people get interested in the technology, people have ideas on the technology, people generate startups, or people build companies, build solutions on that technology and sell that solution for a price, right? So in the blockchain world, you see that the relationship is slightly inverted. Typically, a price is a lagging indicator in any technology, right? But here you see that the Bitcoin price is actually acting as a leading indicator, and this is quite interesting for people wanting to get into blockchain, right? Is that even if you use the price of Bitcoin as a proxy, we'll not get into whether Bitcoin is a valuable asset or not. That's not the theme of this discussion. But if you just track the price of Bitcoin, you would see that every time there is a Bitcoin price that has increased in 2011, 13, 17, 19, now the interest levels in blockchain always goes up, right? And moving on, I did a little additional trend analysis on this, right? And one of the things that you would find is every time the Bitcoin prices increase, the interest in blockchain level goes up. And what does it mean? People then, smart people such as you, try to understand blockchain better and start generating new ideas. So one of the examples for that, or one of the illustrations for that, is if you look at the right side of this chart, around 2020, maybe 12 to 18 months back, we started hearing these new terms like NFT and Web3, right? So this sort of establishes the fact that there is a price, interest, idea, new startups getting generated in this cyclical nature of blockchain. And that so that is sort of a lesson one for everyone, that the way things work in blockchain is not necessarily the same as most other technologies that we have seen in the past. So it's a very interesting area to explore for people. And so with that said, with this trend analysis, I just wanted to talk about what I want to cover in the next 45 50 minutes that we have. I'll break down the session into three parts. One is history and overview of blockchain, how it originated, why it originated. Then we'll start understanding some of the primitives, the technology primitives of blockchain. I'll keep it at a level which is abstract enough, and I'll try to avoid a certain terminology in blockchain that sort of gets people into confusion, debate, opinion, etc. What this session is that it'll not have answers to all your questions, but it'll sort of act as a guide for you to search on yourself, which is what I think will generate interest in the blockchain community, right? And the third part of the session would be, just touch upon briefly about the various industry and solutions that are being built in the blockchain world. Right. With that being said, let's look at the section 1, which is history and overview of blockchain. Right. So why did blockchain originate in the first place, and when did or when did it get popular? Right. So if you look at mankind, if you look at the history of mankind, at least in terms of all the transactions that we do uh, between us, and let's just restrict this focus on financial transaction, for example, right? So typically, as you would know, I think mankind going back in time, civilization, most people lived in tribes, right? And so you had physical proximity, and you also knew the people that you were transacting with. And so when it came to a financial transaction, the barter system worked quite well, right? And as we moved along in our history, people started expanding their footprint, people started traveling more, people were nomadic, and there are also people who were wanting to expand their trade globally, right? And so that resulted in physical currencies, could be silver coins, gold coins, printed currencies, establishment of central banks, etc. And over the last 50, 60 years, it's starting to move more, other forms of money like checks and cards, right? So if you look at this, the transformation, one thing that you would notice is that as we started moving and started doing trade in a global manner, we started moving to new forms of money. The trust between the two actual parties who are transacting probably started getting reduced, right? Because you in most often you probably didn't know who you're transacting with, and this resulted in establishment of many businesses who we can generally coin as intermediaries, who bring the trust in the system, and for that the trust that they bring, they charge you a fee. So that's how this world has been working, at least for the last 150 years, probably, right? The capitalism that drives this world. But what happened? We've also seen that in many instances, and one of the probably the most recent well-known instance was in 2007-8, when the mortgage crisis hit US, and we all figured out that the intermediaries that we trust had actually broken our trust, right? And this happens all the time, and this results in a systemic risk. So what this led to was in 2008, there was a famous paper published by someone or a group of people calling themselves as Satoshi Nakamoto. They published an idea on how can we build a system which enables financial transactions to happen, a peer-to-peer transaction to happen without the need for an intermediary. Now, this has been attempted for many years. There have been projects like digital gold, e-gold, etc. A lot of projects that has happened in the past. But the one challenge that most of them were not able to solve was this concept called double spending, right? What does it mean, a double spending? A double spending essentially means that if I add some money and if I send it to Sandeep, I should not be able to spend the same money on another transaction, right? Because I owe that to Sandeep. And this is what the intermediaries was helping, amongst many other things. They were establishing this trust. And Satoshi's paper defined or proposed a system by which this could be solved. And that was through a process called consensus, using certain mathematical algorithms, generally known as proof of work, but there are other consensus algorithms that are coming into play in blockchain world today, right? I've highlighted few things in this from the abstract that I took from Satoshi's paper. And if you really look at it, if you come from a computer science world or if you've been working in technology, you would know that a lot of things that are highlighted here, peer-to-peer transmission, digital signatures, hashing, message broadcast, all of that has already been in existence for many, many years, right? So it's a misnomer to think that, it's a misinformation to think that blockchain is something very new. What blockchain is, or what Satoshi proposed, is an elegant way of synthesizing many technologies that have already been in existence. So I just want to try to simplify this, right? I mean, I think a lot of times when people get into blockchain, and it's true for me as well, you tend to look at words like decentralized, you tend to look at words like proof of work, you tend to look at mathematical algorithms, etc., and it could get confusing. All right. So one of the things it's good to do, or I try to do, is to simplify things. And how do we look at blockchain, right? And this is not necessarily my idea. This is an idea that Chris Dixon from Andreessen Horowitz has published, and I thought it resonated with me, and I thought it's best that I share with you all as well, right? And this is probably something that how I am also looking at blockchain probably for the last couple of years, right? So this, I would say, is the first principle of blockchain, right? So what is blockchain? The simplest way of looking at blockchain, or you could look at blockchain at computers that make commitments, right? Now, what do we mean by that? Any transaction is a commitment, and one would argue that what is so different than what is happening in today's computing technology, right? They also make commitments. They also help process the contractual relationship between multiple parties. But if you look at it, the traditional computing model, they're either governed by an individual or by an institution, right? So what do I mean by that? Let's just take Google or WhatsApp. Uh, they start a service with you. They provide certain commitments to you, and at any point of time, they can change the commitments, right? And we probably don't even read that agreements. Let's say you wouldn't know, like, how are they using their data? What did they promise when they launched the service versus what are they doing today? So that is what I mean by the commitment is being controlled by an organization. Whereas in a blockchain world, the commitment is honored by code. These code is in general parlance is typically called as smart contracts. And I'm not saying that all blockchains are, conceptually, well, this may be true. Not all blockchains have always done this correctly, but a well-designed blockchain system through this method of consensus provides you this commitments through code and reduces the resilience on human intervention, right? As an example, the Bitcoin, if you look at it, the Bitcoin has a commitment that there's only 21 million Bitcoin that can be in existence at any point of time, right? And that means that, potentially, theoretically, conceptually, you are inflation protected if you are investing in Bitcoin. Now, there is no single organization behind this commitment. There's a group of people, and if you are participating in the network, you are also one of them, who would get to decide that this commitment that the Bitcoin protocol has made is honored. And that is how I think we should start looking at blockchains, right? Blockchains are computers that can make commitments. And a simplistic representation of how this happens, right, is you can imagine blockchain as a set of physical computers that is all connected in a network, and you have and these computers can be called as node. And why do we call it as computers? Because just like any other computers, blockchain deals with a set of data, and the change in the state of data, and the change in the state of data through probably a smart contract, right? A smart contract is a special kind of a program that can prove trusted guarantees between two parties or multiple parties. So if you look at it, what you can imagine is, like, if you are one of the blockchain developers, you are writing a program, you are writing a code. Let's assume that you're building certain blockchain-based system for payments. And what this architecture essentially means is that you are building the smart contracts which is running in your computer, and that smart contract is decentralized and distributed to everybody who's participating in this network, and that smart contract is running in each of their nodes. And the central circle which is represented there, which is called as consensus mechanism. Now that could be proof of work, proof of stake, that could be simple majority wins algorithm as well, but we'll not get into these details. That consensus mechanism actually replaces your intermediary, right? If you imagine that, your program is being verified and determined to be trustworthy by millions of others also in that network through a consensus mechanism, right? So eventually replaced the intermediary through computing paradigm, right? And if you were to have this, and if you were to think that this is the first principle of blockchain, then it helps you understand what sort of problems do you really want to be using blockchain for, right? Uh, and in subsequent slides, we'll also talk about the failure rate of blockchain problems, and that typically comes down to this. A lot of people today are attempting blockchain as a technology because they feel that it's an emerging technology and it can be a solution for everything. But if you were to go back to this architecture at every single time when you design a system, you would understand that blockchain are needed for some specific purpose, and it is best used for those specific purpose. Now, my topic, as I said, is blockchain, why it matters, right? So I wanted to touch upon briefly about why does it matter now. So this is sort of evolution of various technology cycles that we have seen in the world. Uh, Going back in time, 1930s were the first time that a mainframe was introduced, and it took time for mainframes to become prevalent, right? And that probably was around 10 to 15 years before it started getting mainstream adoption. And you started seeing a different flavor of computing paradigm emerge every 15 to 20 years. Then you started seeing mini computers, then you started seeing PCs. And the ones that we probably are more familiar with and we probably are more in touch with every day started happening around 2000, right? Where the mobile as a computing platform started emerging. I mean, we have always had mobile devices, but probably with the advent of things like BlackBerry and iPhone is when we started looking at there could be a lot of computing that could be done on mobile. And then you have this AI cycle, machine learning cycle, and most people who are in the AI world would know that AI and machine learning have been in existence since 1960s, right? But it's just the growth of hardware that has helped reach where it is in the last 15, 20 years, right? And still a lot of things that AI can achieve. And so what this tell, and if you look at now, blockchain is starting to get an interest in mainstream probably for the last 4 or 5 years. And why is this important, right? Every technology, just like any other living being, probably goes through a gestational phase and a growth phase. And typically what we have seen is that it takes around 10 to 15 years for any gestational technology to reach its full potential and reach its growth phase, right? And so why does this blockchain matter now is because blockchain to me is still in the gestational phase. There's just a lot of smart people working in this area. And if you are willing to, believe that yes, blockchains can solve some problem and probably generate some ideas that may or may not use blockchain, but blockchain inspired ideas. In the next 10 to 15 years is when you will see the growth of this, right? So Apple's iPhone, the early version of iPhone probably was not interesting enough. But once they started developing the app ecosystem, that is when you started seeing the power of an Apple, right? Or an Android device today. So blockchain today is still in a stage where the core fundamentals, primitives are getting built and matured, and the ecosystem needs to be generated. And so for an young technologist wanting to work on an emerging technology, if you're willing to spend the next 10 to 15 years experimenting on this or doing research on this, this is a great place to be. So this is again, this is one of my favorite slides, which I want to say is that while Bitcoin does have an interest level generation on the technology of blockchain, but blockchain is not necessarily just only Bitcoin, right? I mean, you can learn a lot from Bitcoin, but there are a lot of other great ideas that you can build on blockchain. So that was the session one, which was history and overview of blockchain. I will move on to technology overview. I hope the space is fine. If there are any questions, please do post it, and I believe the NASCOM folks will have it shared with me, and I can address it. I just don't want this to be a monologue that gets extremely boring for people, right? But for all the technology folks, the next 15-20 minutes, maybe I'll spend some time on the primitives of technology. What constitutes a blockchain, and how do you view blockchain? So if you were to look at what are the building blocks of blockchain, when we say blockchain, what does it mean, right? I like to look at this as, these three layers, which has different functionality, but all of them working together to form a blockchain protocol. When I say blockchain protocol, I'm referring to, say, a Bitcoin as a blockchain protocol, or Ethereum as a blockchain protocol, or there could be other blockchains like Solana, Cardano, and then there are private blockchains as well, which we'll see later. But one thing that is common to all of them in terms of its design philosophy and architecture is that you can look at these blockchains as multiple layers. The most fundamental and the core layer being the ledger layer, which is where your data gets stored, right? And you would have heard that most people say that blockchains are tamper-proof, blockchains have immutability. And how does this immutability happen? The data store, how does this immutability happen? That is done through a combination of the consensus protocol and other techniques, cryptographic techniques, that make sure that the data that's stored in the ledger is tamper-proof. And what consensus helps us is it figures out whether this data should be registered in the blockchain or not, right? As I was saying, that the consensus is the functionality which sort of, in a deterministic manner, figures out whether the data is high fidelity data has that integrity, and the data is not tamper proof, and it can be registered into the blockchain. So that is layer one. That is the core layer of any blockchain platforms. Ledger layer, the data store, and consensus. And each blockchain platform probably have their own flavors of achieving that. On top of that, you would have the computer networking, no different than any other computer networking layer in any other technology. Here we're talking about how do you communicate within the blockchain network internally? How does the nodes in the physical network that we spoke about previously talk to each other? How do they establish peer-to-peer networking? What protocols do they use to communicate the data between the nodes? How do they ensure that they're able to support optimal amount of data, etc. So that is the second layer, and it's in many ways closely integrated with the ledger layer, right? The third layer is the interesting layer, which is called as the application layer or the distributed application layer, right? I mean, so you would hear a term that any application that is built on the blockchain world is typically called as distributed application. And the reason is that if you are a developer, if you are a programmer who built this application, for your application to work on a blockchain world, you would have to distribute it to other participants, right? And that's why it's called as a distributed application. And the core programming paradigm that distributed application typically uses is called as smart contracts, right? Now, smart contracts could be developed in many different languages, but right now most platforms have chosen those languages to be languages that support deterministic nature, right? By that, what I mean is, if you are writing a program which uses a float, I mean, for people who are computer science people, they would know what a float means. Float is a data type to represent, say, decimals, right? And each operating system could have different way of representing them. And suppose you had one node which had an 8, maybe had a representation of the decimal up to only 8 decimal points, but another node allowed you to have that representation of decimal points to 16. And if you had allowed a programming language that was not deterministic in nature, you will never be able to achieve consensus, right? I'm just making this thing simple, but that's what we mean by a deterministic language. And most smart contracts are essentially written in deterministic language. And what does a smart contract typically do, right? An example of a smart contract is, let's say you have taken a loan, and you have a contractual obligation to pay a certain EMI at a certain interest rate with the banker. and the bank is obligated to probably say that the interest will be a fixed or a floating, and if it is floating, they peg it against a certain interest rate, right? Now today, if there is any violation in any one party in any of these contractual agreement, it is a laborious process to figure that out, right? These are all in different systems, uh, in some cases probably even manual paper, and it takes a lot of time to reconcile that. What smart contracts allow you to do that is programmatically embed all that contractual agreements in a program, and when that smart contract executes, it always is able to ensure you that if there is any violation of the agreement by one of the parties, the smart contracts will help you identify it and resolve that dispute much faster than what would happen in traditional world today. That's just one example, but there are just hundreds of different applications of smart contracts, right? And now, if we consider these layers of blockchain, unless you bring in the users into the blockchain network, the blockchain applications probably don't have a value, right? And how do you bring in this users? You have through any typical interface layer. That could be an API, that could be an UI, that could be an integration with existing systems. Unfortunately, interoperability between two blockchains is still not in existence, which we'll touch upon. But this is what you can constitute as a blockchain based application, and how would this work, right? As an example of an interface layer, you would be seeing a lot of advertisements. If you're following IPL, there's just a lot of advertisements around many of these crypto exchanges, right? Coin DCX or WazirX, etc., etc. You could look at that as an interface, right? That allows you to participate in the Bitcoin blockchain network or an Ethereum blockchain network, right? So that typically is the layer architecture of how you could look at a blockchain based application. And why is it called blockchain, right? And maybe this is again an interesting slide, because what is happening in the world today is that we've seen that some of the blockchains, well, they call themselves blockchain, are probably not true to this concept anymore. But yeah, why is it called as a blockchain, right? So the term blockchain originated because the data that gets stored finally, the transactional data that gets stored finally, the way they store it is that every single transaction is hashed. You can look at it as hash as an not necessarily an encryption, but a different cryptographic representation of the data that you sent. And that is why I think people say that blockchain is very secure, because data privacy is maintained to things like hashes, right? So you have this data being sent to the blockchain platform, and after consensus, blocks are formed, blocks of data, and many protocols adopt different techniques of what constitutes a block. A Bitcoin blockchain platform, for instance, they have a fixed size of a block, whereas other blockchains may have variable nature in terms of when they form a block. They could probably form a block after a certain time. Some people may choose to form a block after certain data is getting filled. So you have this transaction. The transaction are collected together. They're hashed and they form a block. And every block has a linkage to the previous block's hash. I don't want to get into too much of details here, but this is the way that they ensure that they make it very difficult for anyone to tamper with the data, right? So mathematically, algorithmically, most blockchain platforms enforce certain techniques that ensure that if a block has been created, they can always validate that the block has stayed true and no change has happened in the block. So if somebody was trying to tamper with that data, let's say I did a transaction with Sandeep and that went into blockchain. If I wanted to make a change to that transaction, if I wanted to change the price of a material that I may have sold to him, that is not possible without having to go through all the consensus layer and breaking this chain, right? So this is how the data is stored in the blockchain, and that is the reason why the term blockchain originated, right? For the folks who are computer science folks who are interested in the data structures underneath driving this blockchain, and you would always hear that Bitcoin system or a blockchain system is, or a Ethereum system or any other blockchain system, they are not having the transaction speed as a traditional technology would have, which is true. And there are reasons, right? I mean, the Bitcoin was designed to solve a certain purpose, and the design ensured that that purpose could be solved with the trade-off that the speed would be slow. Um, but one of the things that people who are real hardcore computer scientists could look at is like, how do I make this better, right? And you may want to start off with how is the data actually getting stored in blockchain, right? So this is a slide which shows like, what is the typical data structure that is used in blockchain, and then there are various variants of the structure in different blockchains, right? So you would hear this term called Merkle Tree. The Merkle Tree is a data structure, a tree data structure that is used to store these blocks of data in blockchain. And it is one of the most efficient data structure to handle uh, summarizing the data and verifying the integrity of large data sets. What do I mean by that, right? Once you start blockchain, right? I mean, it is a sequential data set. You're going to keep increasing the data that goes into the blockchain. And suppose you want to go back in time and find out if a certain transaction happened maybe 4 or 5 years back, it is going to be extremely cost uh, compute intensive if you had used a different data structure, right? What Merkle Tree does it makes it much easier. Here I'm just giving an example, like, if you wanted to find if a transaction C in this existed in the blockchain, what the platform would do is it would give you certain hashes of other transactions that has happened. And as long as you are able to use those hashes and build the Merkle root, which is the hashes of all the transactions that has happened in the blockchain, you would be able to prove this transaction actually worked, or this transaction actually happened in the blockchain, right? And so this is a extremely powerful, very effective way of finding out if a transaction has happened. And this helps prove that the data in the blockchain is tamper proof. And now let's look at what are the key features of blockchain, right? When we say blockchain, and this is again a very, I think it is important for technologists and product managers alike to understand that if you're going to use a technology to solve a certain problem, what are the unique features of the technology that make sense, right? I mean, what are the features of this technology uh, that is interesting for us to consider this technology in the first place for solving a certain problem, right? So these are typically the 5 key features of blockchain. One is it is distributed in nature, which we saw that there are multiple nodes physically connected, distributed in nature. Second, it uses a lot of encryption, provides data security. Third, also we saw that it is immutable. You cannot make a change to the data unless you go through the consensus layer again. The fourth, I'll jump to the left side, which is decentralization, which is one of the most powerful concepts that people are using to build blockchain-based solution. And decentralization is the concept that helps you reduce the role or even remove the role of an intermediary in any business problem, right? And the fifth one is tokenization. What do we mean by tokenization? Is there any asset or an object that you can represent as tokens that get generated into the blockchain world, and that helps make a lot of new business ideas being disrupted, remodeled, rethought. And I wanted to have this slide shared with you, because if the problem that you're trying to solve, or if the solution that you're trying to create doesn't need any of these features, right, then I don't think that you should be really looking at blockchain as a technology to be used, right? I'm not saying that all these features should be used for every solution, but if your solution doesn't need any of these, then blockchain is really not the solution for you. So having said that, I just want to also touch upon like how is the blockchain technology evolving, and what do we think is the next phase of blockchain, right? So as I mentioned, that the blockchain came into mainstream probably around 2008, 2009. I wouldn't call it mainstream, but blockchain as a technology emerged with the advent of Bitcoin. Bitcoin was a public blockchain what do we mean by public blockchain? It is a blockchain which allows everybody in this world, if you want to join the Bitcoin blockchain, you can join, right? And so essentially the premise is that it brings trust between untrusted parties across the world to solve a business problem. Bitcoin was very specific, application specific blockchain. It dealt only with transfer of bitcoins from one party to another party, and most of these networks are incentive driven networks. What do we mean by incentive driven networks? It is essentially you get certain incentives to be part of the network, right? This is why you would hear the term that miners. So what do miners do? Miners are the folks who are running the computers that run the consensus, and they get rewarded for running the consensus because the consensus compute is very expensive, and so they get rewarded, and there is a incentive for them to stay in the network, right? And the most of these blockchain networks are designed in such a way that if any single party or a group of parties try to take over the network, the incentive for everybody else to remain in this network reduces drastically, right? And so people leave the network, and so the folks who try to take over the network also start losing the incentives, right? So this is a very interesting way of looking at the a network effect model. What started happening was from 2014 was uh, uh, this public blockchain network called Ethereum was launched. As I said, Bitcoin is an application specific network. It just does what it needs to. Whereas Ethereum is a general purpose computer network, which allows a lot of cool functionalities to be built on the blockchain based world, right? And what also started happening was that enterprises started looking at how we can adopt this blockchain to a permissioned world where you are building blockchain based solutions between trusted parties, but you are verifying if those trusted parties are honoring the trust, right? And companies like Broadridge, our current focus is in this area, the enterprise DLT area. Since last year, what we are seeing is there is a big re-emergence of crypto as an asset. There are central banks exploring central bank digital currencies, stable coins. You have this growth of things like non-fungible tokens, where musicians and celebrities and sports people are having these NFT tokens, which have some special rights attached to it. And what is also happening from a technology side is people are starting developing solutions which are generically called as layer 2 solutions, which help the transaction speed of this blockchain network go up significantly. And one of the startups in India called Polygon, they have a token called Matich, is a very, very interesting startup. They're doing some really cool stuff on top of Ethereum. And then what is wave 4, right? We see wave 4 as you're going to start seeing this idea of Web3, and we will touch upon briefly as to what is Web3, and you will start seeing many of the technology problems associated with blockchain getting solved, right? And when would you use blockchain? As I said, 98% of blockchain solutions are, not really delivered the result that they promised. And in many cases, it is likely that, the concept of Maslow's hammer theory, right? If you have an hammer, you start to think that everything that you see is a nail, right? And that's probably the reason why most of these blockchain solutions fail. So a typical simple way of looking at when would a blockchain solution should be implemented and chances that it will result in a successful outcome is you look at whether the problem or the opportunity you are trying to address is that a network effect problem, right? And then you look at whether there are parties interacting, a lot of data, there's a lot of messages getting exchanged between them, a lot of communication happening between them. And you look at, okay, are there needs for multi-party workflow here? And then you look at whether the system is today error prone, very manual, operational efficiency doesn't exist. Is there an intermediary today who is entrenched and who has probably a significant share in this market, but not providing the level of services that you would need? And that model, can it be disrupted or not? If you say yes, 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 yes to all these four, then yeah, maybe you want to consider blockchain, right? And the fifth one is if this is a solution that is not in a public network, but between trusted parties, but you want to keep the data private, you want to verify if the trusted parties are acting in accordance with the agreement, Then you start looking at whether you want to use an enterprise DLT or a permissioned DLT or a private DLT, right? So this is a simple way of looking at whether you want to use blockchain in the first place. Having said that, just like any other technology, there's just a lot of technology limitations of blockchain. As I said, it's still in its genesis phase and nascent phase. So some of the challenges that people are facing is scalability. It is not fast enough. And the way people are approaching this is building this another layer 2 on top of blockchain, figuring out what business context you can do off chain and how do you use blockchain only for the data that you really need to be tamper proof. So that is a mature progress. There's a lot of things that has happened. You're also seeing that blockchains are now easily integrated with existing ecosystem through APIs and Swift and other middleware technologies. So that is a solved problem in many ways, as I feel. But there are a few things that need to be solved, which is very important for the business that people want to build on blockchain. One is interoperability. You don't want to end up in a world where there are 100 different blockchains, right? And you don't have a way of figuring out how do you get this blockchains to work together. So that will result in fragmentation, and really the outcome that you predicted that blockchain could help with will not happen. There's some work happening here. Given the time that we have today, I don't want to get into details. And the fourth, the last one is the most important one, which is not necessarily only attached to blockchain, but any digital transformation that we are undertaking today. If you imagine a world where everything is digital, you want to make sure that it is secure. You want to make sure that your identity when you participate in this digital network is protected, private, not shared with others. You also want to ensure that the regulators are able to get enough information about who is doing what. And that is what we mean by controllable pseudo-anonymity. And you want to figure out that, what is the transactions that are happening to ensure that in a network like blockchain, that financial transactions that happen are not illegal in nature, right? This is probably the field where a lot of research is happening, but still needs to happen. And if we don't get this right, most of the blockchain solutions may not really achieve what conceptually people thought it could achieve, right? So if you're really interested in getting into this area, I would urge you strongly to look at this space, understanding the digital identity and how can we build privacy, right? That by itself is a topic on its own, but this is a very interesting space for people to explore. So my final section, I'll just quickly run through what are the things that we are seeing in the blockchain world and why we think that, because of all these things, again, on the topic of why it matters, there's some really interesting, cool things that's happening in the blockchain world. And I just want to give you a sample of various solutions and industries that are using blockchain today. So the first one is, probably everybody knows, crypto, right? The world of crypto is completely tied to blockchain. You cannot have a crypto industry without a blockchain. And if you look at some of the numbers, I don't want to go through each of them, but you can clearly see visually from the graphs that the interest in crypto is growing tremendously, right? What do we mean by crypto? The original crypto was Bitcoin, right? And Bitcoin just continues to grow like crazy. The theory behind Bitcoin is that, as we spoke earlier, it makes the commitment that it can be only 21 million Bitcoins in circulation, which means it theoretically offers inflation protection. I'm not an economist to judge if it is really true, but that's the theory. People believe that Bitcoin will become a digital gold. At the same time, there are a lot of countries who are apprehensive about Bitcoin. Many countries have banned it. Some countries are wanting to bring regulation around Bitcoin. In India, regulation is likely to happen next year. I'm not sure if India will completely ban it, but India probably will take an approach like US, where these cryptocurrencies will be regulated. But what is happening is there is a lot of traditional instruments like exchange traded funds, etc., which is now starting to use Bitcoin, at least in the US, and that is driving tremendous adoption in the investor world, retail world, and institutional world to look at cryptocurrency as an investment, right? if you just look at India, I think the numbers are debatable, but people believe that at least there are 1 to 2 crore investors in crypto, and those numbers mean nothing, right? I mean, they're so small, but it also tells you the road ahead. If this was to become a regulated investment and people started looking at this just like an equity or a bond, there's just a lot of business opportunities for people to build crypto based services, right? And what are the things that one could look to build? You could make to build solutions that help people get better educated about crypto. You could build solutions that makes it easier for people to invest in crypto. You could build solutions that makes it safer for people to build crypto. So these are the opportunities, right? I mean, if you are a young developer or a product manager or wanting to run a startup, crypto is a space that that could be interesting. The second one is, as I said, in each wave, we saw that the first original wave was crypto. The second wave was enterprises started using blockchain, right? And these are some examples of how enterprise are using blockchain. Um, so a couple of areas, there are many areas where it has been very successful, but a couple of areas I wanted to highlight was one on global trade finance, IBM and R3. R3 is a blockchain provider. IBM, pretty much everybody knows. They're working with consortiums like VTrade and Marco Polo Network to build, and they are already live solutions on global trade finance, right? So how does it help, right? Essentially, if you are in the trade business and you're importing or exporting, you would know that there's just a lot of participants that you will have to interact, and there's just a lot of data discrepancy. There's a lot of agreements that you would need to sign. So it is operationally quite expensive, right? And you would have these ERP systems and supply chain systems, etc. But a lack of real-time transparency is a challenge. So one way of solving that could be using blockchain and building the smart contracts which capture the agreements between various parties and giving real-time transparency. That has been successful. There are many firms using this. Again, very nascent stage. And one example of another successful solution comes from Broadridge itself. I mean, yeah, I thought maybe in a 1 hour, maybe I'm allowed to take 1 minute to market our solution, right? So yes, so we have built a solution, multiple blockchain solutions. We have about 4 blockchain solutions that are, in production and revenue earning. One of them, we are using blockchain-based solution to improve and reduce risk in fixed income markets, right? A repo is a short-term trade. You can look at it as a short-term loan between two parties in a bilateral manner. So there's always a risk when you do with a bilateral manner. That is, let's say Sandeep and I exchanging, it is always a risk one of the parties may not hold their word, right? So how do you use a blockchain-based solution to bring transparency into this? How do you use a blockchain-based solution to reduce the cost in this and bring operational efficiency? That's the solution that we have launched. We're already processing around $35 billion trade worth volume in every day, and it is only going to increase, and it will eventually become a marketplace in probably 18 months to 24 months or so. But as I said, still very genesis, very nascent stage of many of these solutions starting to provide value. The third area, which is very exciting, which probably is the most disruptive idea on blockchain when it comes to finance, right, is this growth of what is called as decentralized finance, right? So if you look at finance, you would see that the core banking is already being disrupted by fintech players, right? I mean, you would be seeing all these new neo banks, cards, etc., all of that happening. And the next phase of this disruption in financial services is called as decentralized finance. What do we mean by decentralized finance? Decentralized finance allows you access to all the financial products and services without the need of going through an intermediary. Everything that an intermediary today does is programmed on smart contracts, and the market participants get to decide what the smart contracts can do and not do. And things like how, suppose if you built a loan system using a decentralized finance, what that interest rate should be, what should be the borrowing rate, etc., is all programmatically determined by what is happening in the market through supply and demand, right? So you look at that, there's globally at least 120 billion, close to 120 billion US dollars is already invested in, is logged in DeFi. What do we mean by logged in? It is being put to use for various products. I have just some examples of 3 of the startups that are doing really well. And if you're interested, maybe you want to look at these startups and know more. One is Uniswap, which allows you to trade cryptos, which allows you to convert your fiat currency into cryptocurrency and trade. There's one called Compound, which enables you to generate interest on the cryptocurrencies. And there's something called Aave, right? So these are just some examples, but there are many more happening. And again, if you are interested in blockchain, DeFi is a space probably you want to research more. What would be the future of money? This is an interesting question. I don't know the answer, but what could potentially happen is you already are seeing that the central bank players are looking at crypto and seeing how can they use similar concept. And so a concept that is getting experimented by many banks, including RBI, is something called central bank digital currency, where the central banks themselves will issue a digital currency. It may or it may not be in blockchain. It could be for retail use, which means for each of us, or it could be for wholesale use, right? Between institutions, if they want to settle a lot of money between them, they could do CBDC. The private players innovation that is equivalent to a CBDC in some ways is called as a stable coin. So stable coin is nothing but, many players are trying to say that, I have so many dollars in my reserve. I'm going to issue an equivalent digital coin, which is called as a stable coin. Some of them could be asset backed or algorithmic. You would see big players, Facebook being the biggest one, wanting to get into space. They are doing pilots around stable coins. And this is going to be very interesting space to watch out, right? Because this can have implications on monetary policy by the central banks. Again, I'll finish off this session with probably the most interesting thing that can happen, right? Using blockchain, which is this redesigning the internet or decentralizing the internet with what is called as Web3. What do we mean by it? If you look at web technologies, when it started 1980s, you probably went to internet only for information, right? It was probably read only. You got into internet, sought some information, you got that. And then Google made that experience so much better by coming up with the best search technology. Now, when you moved into Web 2, Web 2 was largely social network driven, network effects. People like Twitter, Facebook, Google started building a business. But what is the biggest problem with Web 2, right? If you look at the graphs below, typically what is happening is the platforms provide you all the incentives for you to join. They attract you. If you're a user, you get attracted to being in Facebook or Instagram or whatever. But over a period of time, your data is just getting extracted for them. They are not giving any value back to you, right? And let's take, if you're a creator, if you're building apps for iPhone or Android, these companies cooperate with you at the start. They help you build applications that help their ecosystem grow a lot. You start building applications on top of applications. But again, after some time, what do you see? They change the rules, right? They change the contracts and they compete with you. So this is something that most people find it very discomforting, the way that Web 2 is happening. These centralized players having a monopoly in the network. And where we are headed to is this concept called decentralized internet, Web 3, wherein it moves to a creator economy and the users play a key role. You can decide what data about you want to share. And that is why I went back to that digital identity being the key building block of Web 3. And again, if you're interested in blockchain, you should explore Web3. You should start looking at what problems can you solve using Web3, right? Can you build a Web3 Twitter? Can you build a Web3 payment system? Can you build a Web3 social network, right? These are examples of people are trying to do it. This is just an illustrative tech, how it will work. As you see that the core of a Web3 platform would largely be blockchain. But the most interesting or the problem that needs to be solved is the privacy preserving digital identity and interoperability, right? Which is something that has still not happened. But as I said, DeFi and Web3 are going to be the most disruptive things that are possible using blockchain. And a lot of people are working on this space and they can make it successful. But what can be the challenges that will make this not successful, right? It is not a technology problem. In my view, technology problems will be solved by smart people such as you guys. You come together, everybody will solve a technology problem. But the thing that could derail blockchain is the social and cultural change challenge around decentralization, right? We as human beings, while we promote democracy, while we promote consensus, but when it comes to a business model, when most of these business models are capitalistic in nature, it is increasingly difficult for people to come to a consensus. So while the technology may allow you consensus, can we as participants believe in that? And can we all agree to an economic model which helps all of us? So, and can we govern this network? So these are some of the biggest obstacles or challenges to the blockchain world, right? And with that, I will end the session.
Thanks, Kishore. I think we have a couple of questions, ask. So one is on the data privacy part of it. So throw some light on the data protection or data security aspect. As there is no intermediaries, hence there is no, it's more prone to the data crime or some light on that.
Yeah, sure, Sandeep. So there are multiple approaches to solve that, right? I mean, I will keep data privacy versus data security as two different items, right? So let's focus on, say, data privacy. An example of that data privacy is that today, if you go to a Bitcoin blockchain or Ethereum blockchain, you would have the history of all the transactions that has happened, right? But you will also see the addresses of who's transacting with whom, right? So that is the first level of data privacy, meaning there is a pseudo anonymous representation of who you are. Let's say a transaction happens between Sandeep and Kishore. The blockchain will only capture the addresses of you and me and not us. That is kept, hidden from everybody. They will validate that we are genuine participants, but they will not show who we are, right? So that is one aspect of data privacy, that the who we are is kept safe. But you also want to keep the transaction itself private, right? Maybe you want to store the details of the transaction private. Let's say you and I did a transaction. You sold a flat to me in some area, right, Sandeep? And you don't want others to know that price for whatever reason, right? So this is where things which are things like a private transaction between in the blockchain network, there are technologies which are coming up which help you do this private transactions. You could still have that transaction done, and things like, as I mentioned, things like layer 2, right? You can have a layer 2 network where this actual transaction happened, which offers you protection, which could be a blockchain or a non-blockchain layer 2. And then you just put the commitment of the transaction into the blockchain network. So this is one way of solving the data privacy, right? Now let's go to data security. The data security, meaning in the blockchain world, you cannot, you theoretically, conceptually, you cannot make changes to the data, and that is solved algorithmically. And they have this theory that unless you have 51% of the network controlled by you, you cannot start making the changes, right? And most blockchains are very, very difficult to attack. Technically, probably it is possible for 51% majority to form and do an attack. They typically call it a Sybil attack. There are enough protections in the blockchain network that make it safe. But as I mentioned, the network is also designed with an incentive network, wherein if you and I join together to make the changes in the blockchain network, Sandeep, people will lose trust on you and they will walk out of the network, right? So what is the incentive that is remaining for us to be in this network? So nobody will, that is one way of building the data security. You will see a lot of news which says that people lost money, people lost Bitcoin, exchanges were hacked, Ethereum was hacked, etc. What is happening is not on the blockchain network, but on what is called as wallets or the interfaces that deal with this network. If that is not securely written, or if the smart contracts are not securely written, you do have this problem, right? I mean, one of the latest example is one of the DeFi networks, the Compound, which I mentioned. They had a error in their smart contract, which resulted in around 800 million or 100 to 800 million dollars being sent to people. and they then realized that they have sent it wrongly, and they reached out to everyone wanting that to be sent back. And many of them who believe in this concept of compound network actually gave that money back, right? Because they know that being in this network has incentives to stay in this network. So these are some of the approaches of solving data security and privacy, but these are not the only approaches. That is what I mean. Like, there's plenty of opportunities for people to come up with more optimal solutions. Hopefully I answered.
Very interesting, Kishore. Due to the time constraint, I'll take one more question.
Yeah, sure.
As we spoke about, you started with the Google Analytics, where it says through the Bitcoin, actually people started exploring the blockchain. I just wanted to kind of understand: are there any use cases other than the financial? Are there any use cases in the other industries?
Oh yeah,
be it healthcare or
definitely. Yeah, definitely. There's actually a lot of projects happening in healthcare. There is things happening on the pharmacy world or the agriculture world, right? Where you want to establish the provenance of the goods, right? Let's say we are still going through the COVID pandemic. You have the vaccinations done, right? And you guys would know that there were incidents where fake vaccines were given in our country, right? In Mumbai or somewhere. Let's say you had a system where you could have tracked right from the origination of the components that actually went into the vaccine to when it was distributed through a combination of, say, maybe an IoT and other sensors, which feeds into this data into the blockchain. Then you have a real-time transparency of that, right? This is called as provenance tracking. So that is happening. The other, as I said, the DeFi is all financial. What is the non-financial equivalent of DeFi? Is the Web3, right? So today you go to Twitter or Google or WhatsApp or any of that, they control your data. How can you build applications where you are in control of the destiny of your data, right? That's the whole concept of Web3, decentralized internet. And that will result in financial and non-financial applications being developed, right? So today, so let's say Sandeep, you are a music enthusiast or a movie buff, right? You make a movie, an independent movie or an independent music. What are your options? You either sell it to Netflix or Amazon Prime Video or Z5, or you go to Apple and put it. What if we all join together and build a Web3 application where you build it, you put it out, and we all make sure that this is authenticated, that we say that this is Sandeep's music. Nobody can tamper with it. Nobody can have any copyright issues with it. We can build a system like that, right? Like Uber is in control of drivers, Uber and Ola. What if the drivers came up with their own decentralized system, wherein they decide who gets to ride, who wants to pick up a certain ride? So these are the potential ideas. But as again said, technology will solve most of those ideas. But socially and culturally, are we ready to be in this decentralized world? Where we trust computers more than intermediaries.
This is actually absolutely interesting, Kishore. Thanks a lot, Kishore. Fantastic session. It's very insightful. I personally enjoyed because I have been trying this, exploring this technology and the crypto market, and I think the blockchain technology is going to grow in the other fields of business, finance, law, medicine, or real estate. And for those in the audience who are aspiring to break into this industry, I think this session would have definitely helped them a lot. I think. Thanks once again, Kishore.
Thank you, Sandeep. Thank you, NASCOM and NASTech, for inviting me. Thank you once again. Have a great day.